So here in this notebook, we will do some of the writing, and again, this will be available to you. I'm not sure if anyone tried to access this OneNote, but the idea is that it is synchronized with like what I do here on the program will be synchronized to this note, and you can open it from nearly any platform. So this is a common notebook for us. So this is the first entry here in the channel, and the experimental part. Now I will open the webcam and show you a few things, but from previous trials we have found that it's not very clear. So I did a video, I've recorded a video and uploaded this to YouTube, and this is more clear. It will have better resolution, and you can see the steps better than live streaming here in Teams. Okay, so this is part number 2. We'll come back to this. Okay, so let's open the manual and see what we'll do. Now, the lab is DAC6, sorry, DAC2, data acquisition part 2. So this is very simple. We will apply like basic electrical measurements. Basically, we will measure current, voltage, and we will calculate power, equivalent resistance, and like these elementary circuit variables. Okay. In addition, we will learn how to use the breadboard and how to simulate a circuit using multi-sim live. Okay, so basically we will build the circuit in this simulation environment. We will simulate, we will obtain our voltages and currents, then we will construct the circuit for real and directly measure those voltages and currents and compare. Okay, we will compare the simulated values and the measured values. Okay, we will stick with the same hardware, the NILVIS3. Now what you will obtain at the end is just current and voltage values. So we will, after we perform the experiment today, we will directly obtain the results. So you don't have to come back later on and collect data. We will collect them directly during the lab today. Okay. Okay, Shab, you understand? You are following? All right. So let's go back to the manual. All right. So now let's have an introduction about power supplies. Okay, and our objective today is to analyze basic electrical variables: voltage, current, resistance. Basically resistance. We will not do other components. Okay. So power supplies. This is the first thing you consider in an electrical circuit. Okay. Now, mainly power is interacted or received through two variables, either voltage or current. Okay, mechanical variables in the mechanical domain, this can be force or speed. All right. So here in the electrical physical domain, we have voltage and current. So we either have a voltage source or a current source. Right. Mostly we deal with voltage sources. This is how electrical power is transferred, is through voltage sources. Right. Now, all right. So here we can see in this picture, we see two different forms of voltage sources or power sources, electrical power sources. Okay. Now on the left here, what do you see? Who can tell me? This power supply here. I think most of you know this one. You should know this one.
It's a car battery.
Car battery, right? So what's the voltage on that car battery? You know, car batteries.
It's a 12 volt DC
12
battery.
volts, yeah.
exactly. So car batteries operate on 12 volt DC. Okay. Now the second question about such. Now we have two things, right? We have the voltage level. This is 12 volt, and we know that this is DC, right? We know the meaning of DC. DC means the voltage is constant all the time. So here you have 12 volt, and the voltage is constant all the time. Okay, so this is direct current or DC. Now, next question is the capability of this battery or this voltage source, right? Now, before we go to that, let's have another example on voltage source. Here, what do we see? All our homes operate on this electrical plug. Okay, so this is a 240 volt, but this time this is AC. Okay, sure. Now, AC means the signal is going up and down like this in a sine form. Basically, you have sine waveform. Okay. Now, the importance of these sources is to be able to select the proper power supply or power source that is that can fit to your application. Okay, so this is the importance. Now we need to understand how to do that. If I have a load, a DC motor or a light or a heater, maybe, how to select the proper power supply that can fit my application. This is the objective of this section. All right. Okay, so here we have seen two examples. A third example, this is a laptop power supply. So let's see the specification of this power supply from the label sticker here. Okay. Now I see that the input for this supply is this one, from 100 to 240 volt. What does this signal mean, or this sign? Okay, this sign means AC. It has to be AC. Now this is the input to your actually this is a power supply for a laptop. Okay, so I have flipped that. I know I've seen the sticker. I think most of you can see this if you are working with laptops. If you flip the sticker, you will see that this power supply requires this input from 100 to 240 volts AC. Okay, this has to be AC. Okay, now what does this mean? 1.5 ampere. Now this means that the power supply or the input to this power supply, let's say we are using the 240 volts, it has to be capable of delivering at least 1.5 amperes. Okay, so this is the maximum current that this power supply will draw from the 240. We call it mains. Okay. This is the mains. Okay, sharp. All right, now 50 to 60, this is the frequency of the input sign. Okay, this is this. Now, the output of this power supply is here. Now you can see that this power supply is delivering 19.5 volts. Now this signal means DC. This signal, this sign here means DC. Okay, and the 4.62A, this is the maximum current deliverable. Okay, so this is the maximum current that this supply can deliver. If you have another laptop and you want to use this power supply. Does it work or not? Okay, now this is a Dell power supply, and this is specific for the laptop, so you don't have to worry about these. Now we have another Dell, and that Dell requires 6 amps at the same voltage, 19.5 volts, and it requires 6 amperes. Now that laptop requires a higher current than the capability of this one, of this power supply, so you cannot operate that laptop or that load using this supply. Okay, this is the importance of knowing the rated voltage and current for your supply. Okay, now this is summarized here in this steps. Now the question is, let's put it here. Okay, power supplies. The reason I'm explaining this is that we have a lot of occasions during SDPs that students need to select power supplies. So having the basic knowledge on how to deal with these supplies is very, very important, because I think there's high probability that you will need to do such power supply selection. Okay, so first thing, I have a load, right? This is a generic way to select a power supply. Okay, let's flip this like that. Okay, so my interest is the following. How to sort this pen. Okay, so how to select a power supply. Now, of course, you have an application, right? You have a load. You consider this as a load. Let's have it like a box like this. And this is your load. What's the first thing you need to do? Now I want to get a supply. Okay, let's see. Supply, power supply like this, and connect them together. Now my question is about here, how to select this supply. Okay, now the load or the ratings of this load, basically the voltage rating and current rating. Okay, knowing these information will enable us to basically select the proper supply. Now here we are assuming that I have the load, but I don't have the supply for that load. I have to select it myself. Okay, let's be more realistic. Let's have an example on this. Like this can be a DC motor. This can be a valve. This can be a heater coil. Okay, a lot of things. All right. So how to select the power supply? This is the question. First thing you need to answer is this. Now this is summarized here in the manual. Now what does your load or your device require? Does it require AC or DC? Okay. For example, what does my laptop require? Who can tell me? Does
AC.
AC, ليش?
And after the 240 volts, there's like a wave.
Oh, now this one here, this is the input to the power supply to the laptop. Now assume that your power supply I think all of you know this power supply, right? The black triangular box thing. Yes?
Yes.
So this is my power supply. Say this, you don't have this power supply. For some reason, اخترب. It doesn't work. You have to get a new power supply for your laptop. Now, my load is my laptop. Okay. Now, say this sticker, you found it on, on your old power supply, and you want a replacement for this one. Now, I know my load here in this case is the power supply itself. Who's sending me chats? Let's see. Yeah, so does your laptop now, this AC is for the transformer that supplies the laptop. But the laptop itself will take the output from this transformer. So in this case, does my laptop require AC or DC?
DC?
DC.
No.
Okay, so we can conclude this from this sign here, 19.5 volts, and this means DC. Oh, شو اللي صار عندي? Yeah, this means that your laptop requires DC. Alright, خلينا نعمله as an example laptop. Now it requires DC. Now next question, what's the voltage level? Now my laptop requires how much the voltage level, شباب? Are you following ولا confused شوي?
19.5.
19.5. Okay, so this is the requirement of my laptop. خلينا نشوف here. So it requires 19.5. So can I buy a 12 volt supply? No, in that case you cannot. Can you operate your laptop on car battery? Does it work as a supply?
No.
Of course no, because the battery gives you 12 volts and you require 19. Okay, so whatever supply you need to use should deliver 19.5. Now this voltage is constant. Right, next question is, what's the current requirement? See, this is your voltage and you have here the current. What's the current requirement of your load? Now from this one, what does my laptop require as current? Now the answer is here. This is the maximum current that your laptop requires. Now why do I say maximum? I'll tell you in a moment. So 4.62 maximum current. Okay. Now usually your loads, a load like this, if you have a load, the voltage should be constant, which is this 19.5. So if you draw here your voltage, it should be constant at 19.5. But the current, let's say I. Now the current can be variable. So the current, maybe at the beginning when you turn on your laptop, you have a high current like this. When the fan goes on, okay, so you have a fan, you have the lighting of your laptop, you are powering the speaker, you have a lot of load, the current can go higher. If you put your laptop to sleep, the current can go less. So the current is variable depending on load conditions. Right? However, the voltage should be constant all the time. Here, voltage should be constant. Okay, Shab, you understand this point? Another example on this, if you have a DC motor, let's say I have a motor like this, and you have a shaft here, okay, and here, say this DC motor requires 12 volts, and the maximum current, it needs 2 amperes. Now I know, based on this, I have to select a power supply that gives 12 volts, no more and no less, but the current should be at least 2 amps. Okay.
Mr. Ali, I have a question.
Yes.
Please.
Yes.
It's very elementary, but I never got it. What do we mean when we say we apply a 12 voltage or a 12 volt voltage? Like when we apply a force, we understand that we are applying a force. But
Yes.
physically, what do we mean when we say we are applying a 12 voltage across a certain load?
Oh, very good question. Okay, let's see that. Now, here, imagine you have a car battery like this. This is the positive, this is the negative, right? Now, by applying means you connect the circuit simply. And you connect a wire, let's put it like this. You connect a wire here and another wire here. Now, this can be manual or can be by a switch, electronic switch. Like you see, when your car is hot, what happens? An automatic relay will switch on your fan. Okay, now this is a good example actually. Let's take this as, let's change this. It's the same actually. Let's say car fan. Car fan. The car fan, what does it have? It has a DC motor. Same way, DC motor, but here you have blades. It's hard to draw these blades. This looks like a rose more than a blade. Okay. So here you have the air like this. And you know, why does this happen? Because here you have the radiator in your car. And this has to blow air on that radiator to complete, you know, the cooling heating cycle in the car. Okay. So how does this work? Here I have a DC motor. This is a realistic example. Yani if you open your car now and extract this motor, you will see there is something volt and something ampere on it. Okay, are you following? So
Yes.
yes. So for example, this is the car fan. You have found you went to the market and bought this fan, but you want to operate it externally. So you are developing a new project where you are using a car fan to heat or cool maybe a solar cell or maybe some fluid system, depends your work. Okay, now could I use the 12 volts that I can plug in the socket? And you have this is as car battery. Okay, you might have, you know, these let's call them socket transformer like this. Okay, you know what I mean by this? The socket transformer?
No.
You know, like your phone charger.
Okay.
Yeah, something you plug. It has same 12 volts. You know, the car battery has 12 volts. Okay, so which one can you use to operate this as DC motor, as a load? Now, you know, if you go to the motor itself, you'll find a sticker or maybe a serial number. You go online, you search on that motor, the DC motor model. Okay, and then you found that this motor requires 12 volts and up to 2 amperes. Okay, now you have the specification for your load. You know how much power your load requires. Now the next mission or the next step is how to select the proper power supply that can really drive this this fan or this motor. Okay. Now by applying, meaning just connecting like this. Usually you have a switch. You have a switch like this. So applying meaning closing the switch. Okay, sure. So مين سأل كريم?
كريم نعم.
Yeah. So I don't know. You get the idea?
Yes, it makes sense.
All right. Perfect. So this is the focus is which one to select. Do I select this one or this one? Or maybe you have a solar cell. Oh, you bought a solar cell, and the solar cell says, I give you 12 volts. So all of them, they give you 12 volts. The solar cell here, this socket transformer, and your car battery. Which one can operate this fan motor? The answer is, you need to know the current requirement for this motor. It says here, you have knew by some means that the motor requires 2 amperes. Now you need the source that can deliver at least 2 amperes. The answer to this is get a 12 volt supply that can deliver at least 2 amperes. Why do we say at least? Because you see all of these sources, they all say that I will give you 12 volts. But what's the difference between them? Now we know this solar cell is weak, it doesn't give you high current. The socket is moderate, it can give you half amperes. But the car battery can give you very high current, maybe 200 amps. Okay, now all of them on the voltage side, they will give you 12 volts. But the current, as we have seen, the current is variable depending on the load condition. So depending here on the condition of the load of this motor. If you have friction, if the car is moving, now you have a resistance air. This will maybe load more or less your fan. So all of this will give you variable current. So I is variable or current drawn by your load is variable. So variable, but it says here 2 amps. It means that at maximum, if you load the fan or the motor as maximum, it will take 2 amperes. Sure. So if this says half ampere, you cannot get it. Usually the solar cells, they can give you maybe 0.2 amperes. It's not a good choice. Car battery says 200 amps, so this is more than 2 amps. So basically this is a good choice like this. Okay, شباب, so I don't know, is this clear?
Mr. Ali, I have a question
Yes.
here.
Yes.
If the battery is supplying 200 amps, so our load only needs 2 amps, doesn't this cause overheating or something similar
No.
It ruins our circuit.
No. As long as the voltage is 12 volt, okay, this is 12 volt, we agreed on this. So this is same as the load, right? No problem here. But the 200 amps means 200 amps maximum. Okay, خلينا نظبط هاي. 200 amps maximum. Doesn't mean that at any load it will operate 200 amps. No. It gives you the capability of this battery. Or you can think about it as the muscle or the strength of this battery. So it says here, I can give you up to 200 amps. Okay, so here your load is moderate. It's asking for, let's show that. This is asking for only 2 amps. Yeah, so this is within the capability of this battery, so it's fine. Yani not necessarily it will give you exactly 200 amps. It's just the capability of this battery.
Okay, tamam.
Yeah, so in the car, if you go to the car, what do you have? You have your sound system. صح? You have what? Your maybe lighter, cigarette. Lighter. What do you have else? A lot of loads. You have AC fan, or they call it fan blower, I think, or AC fan blower. All right, your sound system can require up to 5 amperes, depending if your volume is maximum or minimum, blah, blah. So this will take up to 5 amps. Cigarette lighter, there's a heavy load. It can take 10 amps. AC fan blower, this may be 15 amps. So all of these are loads connected to your system. Okay, basically your car battery or the battery plus the generator. Okay, so you can see here that you can imagine it like this. This is your car battery. Okay. This is your plus. This is your minus. Okay, now I have load 1. You have load 2. You have load 3, etc. So load 1 is taking some of the current. Load 2 and load 3. Now this is the negative is here. Okay, so you see that here it's giving maybe I don't know, if you assume that these operate at the maximum, عندي 20 30. So here you have 30 amps. Does this mean that this takes 30 amps? No, this takes 5. This takes 10. This takes 15. Okay. So whenever you deal with current, you can imagine it as water. The water is flowing like this. Some of it will go here, some of it will go here, some of it will go here. So I hope I answered this current question. Okay, Shahab, is that clear? Any point to be repeated?
لا, clear, Mr. Ali.
Doctor, I have a question.
Yes, please.
Okay, الحين مثلا for example if we have a device that operates at 12 volt, okay?
Good.
And we have 2 sockets, one 12 volts and one 15 volts. If we plug the 15 volts, does that mean it will charge faster?
You said you have a load that operates at 12 volts.
Yes.
Only 12. It did not say from 2.
ما أدري هي okay.
Yeah, so لا, having a load like this, your load says 12, and you have 15 and you have 12 صح?
Yes.
If you connect this, now probably you either will burn this or this. But that depends on the nature of the load. If it is electronic device, if this is electronic, probably you will burn something. But say if this is a heater, يعني just a wire, you know, just a coil like this.
Yes.
Yeah, this will operate, but you will overload your coil. يعني ما يخترب شيء بس you are overloading. So something wrong will happen.
Okay. And if same scenario, but 10 and 8 volt.
Yeah, same scenario.
No, but the 10 will charge faster than 8?
Charge, what do you mean? Now you are talking about a battery, صح? You are charging a battery or a phone or something.
Yes, a device.
Yeah, so that device should be able to withstand that voltage. Now, you are talking about charging, so I conclude here you are talking about maybe a battery, صح?
Okay, yes.
Battery or a phone. Now, for example, some phones, they operate only at 5 volts. You know, the Samsung or the, you know, the regular USB, the USB mini.
Yep.
Mini or some iPhones. They operate at 5 volt. If you put more, the phone has some protection against this. Say you said, hey, I want to put 8 volt because I want to charge faster. Now, the old phones, they don't accept this. They disconnect, or probably something wrong will happen, but they usually have some protection against this. So putting more voltage is not always better to charge faster or to make things work faster. Now the new phones can accept from 5 up to, I don't know, 20. Some of them, not all of them. For example, USB-C, I think you all know USB-C. The USB-C is USB-C. Is this socket job? So you all know it, I think.
Yes.
Yeah. So for example, this one, I can charge my phone using 5 volt. I can charge it using 5 volt. This is slow charger. And up to, I don't know, on the, yeah, I think it says 20 volts. This is super fast charger. Why can I do this? Because the device has the capability to handle such voltage range. So if your device can withstand higher voltages, yeah, it will charge faster. But if it doesn't, probably you will burn something. And here says 12 volts specifically. You have to stick with the 12 volt. Okay, this is what I will do. All right. Now, batteries, charging batteries, it has a separate way to deal with them. You have to, I don't know, I don't want to talk about them, but batteries, they usually have the current, we call it charge storage in milliampere hours. Usually take this and divide it by 5 to get what you call charging current. Okay, say this is مثلا you bought, let's give an example. مثلا in the market you see 10,000 milliampere hour power bank. صح? You see such a thing? These power banks. Okay, so here it says 10,000 milliampere hour. Okay, so this is the capacity of this battery. Not every load has this specification. This is because it's a battery, so it stores charges. So they give you the capacity of charge storage through this parameter here. So this is specific for batteries, 10,000 milliampere hour. So 10,000, I think they divide it by 5. They get what? You have 2 amperes, so you can charge this battery up to 2 amperes charging current. Okay, guys, so battery charging is not a straightforward topic. Marif, did I answer or did I confuse? So now, generally, this is my circumstance. I have, let's see. You have a DC motor like this. Okay, let's take this as an example. I will copy image. Let's put it here. Okay, Shabab, are you following? Say your application required this motor. What is a good power supply to operate this motor? Who can tell me? Shabab, are you following?
24 volts.
24. It says here 24. So this means I need a socket supply that says 24, or maybe 2 car batteries. Okay, but what about the current? It doesn't say here the current. So you have to take this serial number and go to what you call data sheet for this load. Okay, so let's see. Now I know the voltage, but I want to see is this operating voltage or a maximum voltage, and what's the current? So you see, you go to data sheet. All right, so you see here that there is something called voltage range. So basically, not operating voltage, but maximum voltage. The 24 was the maximum voltage. So I can operate this motor from 12 volt to 24. All of them will give me different RPM. Okay, so my supply should be able to, let's see the ampere. Yeah, you can see here the ampere. Now at no load, if you don't load the motor, it takes 0.08 amperes. Now at maximum efficiency, let's see, the current is 0.41 maximum. Now at maximum power, this is what I want. I have تقريبا 1 ampere. Okay, شباب. So basically, I know from this that I need 24. I need 24 volts DC power supply. That should give me more than 1 ampere. Because my maximum load condition here said 0.99 max. So this is at maximum power. Now this is the maximum current at the maximum voltage. So I'll get a power supply like this. Okay, Shabab. Is that clear?
Yes, clear, Mr. Ali. Mr. Ali, in the spec sheet here, in the table,
yes,
there is an efficiency column. What do they mean by efficiency? Efficiency in converting electrical to mechanical?
Yeah, now here you are converting electrical to mechanical, exactly. But you have losses inside the motor because it has internal resistance and internal friction. So here, this is a parameter that probably says the maximum output power to input power. That will minimize losses. This happened because this is brushless ولا شنو? Electrical manufacturing company. I think this is a permanent magnet
Yeah, I
type
think
of
this
motor.
is brushed. بالprevious
Yeah.
tab it says electric brushed motor.
Brushed, yeah. So you have losses in the brush. You have losses, magnetic losses inside the stator and the rotor. You know, because you generate magnetic field around the motor, so you definitely have losses. So if you ask for more load, you will get higher torque, higher parameters, but the efficiency itself is
Will decrease, yeah.
Yeah, it seems that this is a variable. So here I think they give you this plot, this symbol here. It says the maximum efficiency is around here, which is to operate at specific torque or maybe specific current, specific voltage. I don't know. So this is the efficiency curve. Okay, so usually you get this motor because you want specific torque or RPM. And you have a gear reduction gearbox to either raise the torque or raise the speed. So this is part of a design. This can be an important parameter in the design.
The gearboxes are in brushed motors only, yes? I'm sorry if this is not related to the lab
Yeah, it's
topic.
okay. It's okay.
Gearboxes for reduction are used in brushed motors only, yes? Well,
لا,
even brushless ones.
No, not necessarily. You have them everywhere. In brushless مثلا.
Speed controllers in brushless motors يعني بيكون
لا مثلا خلينا نعطيك example. درون بالدرونز.
Yeah, exactly. No, I'm asking because I know in drones there is an electronic speed controller and a brushless motor.
Brushless, and there is a gearbox. Some of them they have gearbox. يعني there's no ما في شيء يمنع إنه to use a gearbox. Which ones? I've seen few of them. They have gearbox, but not reduction. This is what do you call this? To amplify speed, not the torque. Okay.
Okay.
I don't see an example. Yeah, see this one, for example, there's a gear drive here. So this one can mesh to a higher gear size or to a lower gear size. Okay, but no, gearbox, yeah, it can be anywhere. يعني ما في شيء يمنع. Okay, so this is this. Now, designing such mechanism is like separate topic, so I will not go through that. But in general, these things, they belong to mechatronics. Why? Because as a mechatronics engineer, you need to understand this motor specification, and on the mechanical side, you need to understand the mechanical design, etc. So such a thing usually mechatronics engineer will handle. Yeah, and the drill, that one is a universal motor. Yes, Nawar, you said they are used in drills. Yeah, some drills, they use the cordless drill, they use brushless. Some of them, they use brushed DC. The high voltage, the ones in the 220, they use what you call universal motor. Okay, so anyway, so the topic is I have a load, regardless of what it is, and I want to select the power supply. I hope, Shabab, you can answer this question. Okay, usually you get these questions, DC or AC. مثلا brushless motor, does it need AC or DC?
DC? Brushless?
DC, yes. But inside the motor, you don't have DC. The controller will convert this to another form of the signal.
Don't all motors have AC current inside them?
Yes, yeah, you can say AC, either due to mechanical commutation or due to electrical commutation, depending on the type. But inside of them, yeah, you have something variable. You can say AC. But مثلا, if you have a DC motor like this, you can directly hook it up to a battery, right? A battery like this and a battery like this. So this is DC motor. DC brushed. And inside the motor, the commutation will happen. But if you have brushless, we'll handle this in the DC motor lab. So we have this. The brushless have to have a controller. We call it controller, not necessarily controller. The exact engineering name is the driver. Now, these days, you have them integrated controller plus driver. Driver يعني electronic circuit that gives you enough current. The controller is the logic, the brain of the thing. And here you have your supply plus minus. This is a DC. Okay, شباب. AC motors, no. AC, they don't operate necessarily directly in DC. You have to supply AC directly. So it's another topic. Type. We can answer now AC or DC. Does it require voltage or current supply? Most loads, they require voltage. Current supply, some loads require current, like LEDs. If you go buy a LED strip from the market, the specification on them is current. Okay, LEDs require current, regardless of voltage. Okay, but mostly voltage source. Now, what's the value in case DC or amplitude in case AC of the required voltage or current? We can answer this. Now, if it is a voltage, what's the maximum current? If it's a current, what's the maximum voltage? Usually you have both. They can be variable, as in the case of the DC motor you have seen. They can be constant. Most lights, they operate at constant current voltage. So it depends.
Doctor,
Yes.
now when we say voltage supply, we mean like battery, صح?
Yes.
Okay, and current supply?
Current supply, it's actually a voltage supply, but the voltage is variable, and you can fix the current at some value. خلينا أعطيك example. You know the LEDs, right? LED strip.
Yes, colorful.
The LED strip, these ones, you know them, right?
Yes.
Now these ones, they usually require current. Yeah, they tell you, I need 1 ampere. What does it mean? Now your load is current. It says whatever voltage, give me any voltage, but I need 100, I need 1 ampere. So your source has to be capable of delivering that current. خلينا نفرجيك example. Now this one says 12 volt. خلينا نفتح اللينك. It says 12 volt LED strip light, blah 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 blah. Now it says 12 volt. شو يعني? I should supply 12 volt. Now internally, this doesn't come like this. It has to come with. خلينا ندور هون. Yeah, you see, it says working voltage 12 volt DC. تمام? So you can hook them up directly to a 12 volt DC. But where is the transformer for that? they usually don't come like this. They have a transformer or what you call the driver. خلينا نطلع another search. Okay, this can be a good example. All right, so you see this one, it's a lid actually, but here خلينا ناخذ هالimage هاي. Copy image, let's put it here. Okay, all right, here there is a box. You see this one? Michal?
Yes, doctor.
Yes, so Abdullah, صح? Abdullah? Yes, so Abdullah, here you see there is a box here. Now this box will deliver constant current I, and here you give مثلا 12 volt that comes from this transformer. Here you have 240. This method will give you 12 volt. Now this box here, it can be outside, sometimes it can be integrated on the lid, is to give you a current source. This is current source. So current source, it tries to maintain a constant current, to maintain a constant lighting on the lid, regardless of the voltage. Yes, you agree?
But doctor, this box is not the receiver for the remote, for to change the color?
This one? This one?
Yes.
Maybe. I'm not sure. So I have to really buy it and see it.
Okay, I understand. Thank
So these let's see. No, if it's the receiver, why does it get here a power from this and gives the lids like this? I think it can be both, right? So it depends on this particular product. Okay, another example on a load that requires current. Charging batteries, usually it should be specified by current. So they tell you charge this battery at half ampere. This means let the voltage be whatever it is. It can be variable, but fix the current at this value. Okay, شباب? All right. Now this is this. Enough of this introduction. Okay, so any question on this? But as an exercise to you, here in this page, there is a question. It says, given this DC to AC power inverter. In the PDF, does it show? Let's see. الحين احنا ما بدنا نصرف وقت كثير هيك. Okay. The PDF doesn't show. طيب, I will update the PDF, but the idea is clear. Now, I will leave this as an exercise to you. It's an example on, I have the power inverter. This is in the cars. Okay. Let's steal this figure. Okay, شباب, you have this inverter. So what does it do? هذا inverter شو يعني? It takes 12 volt DC on this side from the car socket, and it transforms DC to AC. Now this can be 230 volt AC. This means I can connect this to maybe any supply that, or any source, any load that requires 230. Of course, you have other outputs here. You have 5 volts, you have other things. Now the question is, would it be able to power the laptop here in this figure? This figure. Now I'm considering the power supply as the load itself. So I have to look here. This requires this voltage and this current. So does this power inverter, is it able to drive that laptop or not? Okay, so I'll leave this as an exercise. Passive elements, we know resistors, right? We know capacitors from physics, you should know all of these. And we know inductors. Okay, this is just an introduction. Now here in these figures we see different packaging for these elements. Now these are like element resistor. Sometimes you have a resistor that is a heater or a coil, or inside a motor you have the windings, the field windings. These have some equivalent resistance. Yes, but this is the circuit element as a resistor. Okay, these are capacitors. You have different types. You have AC, you have DC, you have bipolar. Capacitors are important, specifically in op-amp circuits. You need capacitors and filters as well. Inductors, they're less common, but they are used in oscillators and power applications. They can arise because in motors you have a coil inside. So the coil has a resistance, an equivalent resistance, and an equivalent inductance. So these are inductors. Now I'll focus into two things today. I need to simulate a circuit, basically resistive circuit. How to use protoboard. Now this is done by video. If I do it live today, it will not be clear. So this is done by video in the channel. You'll find it here. This one here is the experimental parts. We will do it later on. Now we'll see how to measure voltage, current, and resistance. This is straightforward. Again, this is in video. How to calculate power consumption of electrical component, equivalent resistance of resistive electrical circuits. Okay, so all of them are elementary, and there is nothing tricky about them. How to delete. All right. Okay, so these are our objectives today. Now the equipment, we'll use Elvis 3 because it has the prototyping board, or what you call the breadboard. So this as an attachment. We'll use Measurement Live. This is an online tool that enables us to simulate any electrical circuit. Physically here we will use resistors 220, 560 and 1000 ohms in addition to probes. All right, now this is my circuit. Let's analyze it. Now I'm going to take this figure here to the one knot. All right, so I have a circuit like this. How to calculate current and voltage. In the lecture part, you are dealing with this now, or you have finished analyzing circuits?
We finished this in chapter 2. Now we're in chapter 6, I guess, or 7.
Perfect. So you know mesh analysis, nodal analysis,
Yes.
current.
Yes.
All right. So this is a trivial circuit. It's very easy. You have a source here. Now, what does the symbol mean? It means this is a DC. Okay, sure. If it was AC, usually you have it like this in the circuit. You'll see the symbol. You know, the generic power supply is like this. You have plus and minus. Usually AC, they are denoted like this. There is a sine wave here. Okay. So generically, this is a DC, and formally, these lines here, they mean it's a battery. So these, do you see these strips or these lines? They're just like cells inside the battery. Just, this is historical symbol. Okay, so this is the supply. Now what do I have here? I have, okay, so I have, okay, how many variables do I need to describe this circuit? How many currents?
2.
2. Why?
Because the current, we have 2 loops. So
You have 2 meshes. Right?
yeah,
So
exactly.
if you approach this through mesh analysis, you have I1 like this, and you have I2, and then you can continue. So knowing I1 and I2, you can find everything. You can find the voltage here, you can find the voltage here, you can find the voltage here, you can find the power from this resistor, power, the total power, everything. Okay, so you need at least 2 variables. Now we will approach this like the approach you used to do in physics, which is like analyzing this by sense. So here I'll assume I have a current, I'll call this I1. I'll say I have another current I2 and a third current I3. Okay guys, how many voltages do I have? Or how many nodes? This is the proper, how many nodes in this circuit?
1. Oh, 2.
This one?
It's between R1 and R2.
Yeah, so what about this node here?
Oh, yes, okay.
Yeah, so we'll call this V1 on node 1. We'll call this V2 node 2. Of course, all of them are with respect to ground. You agree, Shabab? And here V1 is, where's the plus and minus for this V1? Of course, all of the, like when you do this analysis, you assume that everything is with respect to this ground, which is here connected to the battery negative or the source negative. We'll see this physically, how we can do this. Okay, so all of my voltages are respect to ground. Okay, Shabab, you understand this point? Yani V2 is actually, the plus is here, you have V2 and the minus is here. So this is the minus. Because you know the voltage has polarity, so you have to assume the polarity. Now having a ground, you can assume that everything is with respect to ground. Okay. Now how to calculate, I'll leave this to you, Shabab. Okay, unless you want me to do it, I can rapidly analyze the circuit. Anyone want to see how we can find these, or how to calculate these currents and voltages?
We do Kirchhoff's voltage law.
Kirchhoff?
Yeah.
Yes.
KVL.
KVL. So you can.
With KCL for the current.
You can, yeah. But yeah, you say that I1 is equals I2 plus I3. All right, so if you make a loop here, you say minus 5 plus I1 times R1 plus I2 times R2 equals 0. So I can say here 5. Now I know R1 and I know R2. So this is an equation with 2 variables. You can make another loop here. You say I3 times R3 plus, now here this is minus because I'm moving clockwise. So minus I2 R2 equals to 0. But R3 is, I3 is what? I1 minus I2. So you can put here I1 minus I2. This is equation with 2 variables. I1, I2, here I1 and I2, you can solve this. Okay guys, now it's not an objective today to this analysis. I will simulate. Now we need to learn how to use the tool to simulate. Because as an engineer, not every circuit you have to do this calculation. You have a tool to simulate. Okay, now this is the first thing we will learn, which is how to use multisim live in order to simulate a circuit. Okay, sure. So we are doing the experimental part A, okay, which is the simulation. Now multisim live is an online tool that you can use to build and simulate circuits in a realistic form. Okay, so you can scan this code or browse to multisim live. So let's have this link. I think the PDF you have has this active, so you can open this link. All right. Okay, Shab, so we need to do this together. In case you are not following, please stop me at any time. So this requires that you make a profile. And
Mr. Ali, should we log in on this?
Yeah, you need to look. Yeah, so let's log in. Now it is slow on my side. I don't know why. Yeah. So here you need to make a profile, actually an I profile. You see this automatically. You are directed to ni.com. So you need to make an I profile. Okay, I already have one, so I'm going to log in. All right, so this is my multisim live. Okay, sure. Do you need time to make this step? Should we pause a little bit on this one?
Yes, please.
Okay, sure. So I think when you activated LabVIEW, you had to make an I profile. You can use that. Okay, let's spend 5 minutes on this until you make your profile. Good job. Are you proceeding? Is there a difficulty?
No, it's fine, but I forgot my password, so I'm resetting.
All right.
Mr. Ali, do we have to enter a serial number or can we skip?
Serial number? No, you can skip. Make it as trial or as without a serial number. There's an option to proceed without a serial number, I think. I really forgot how to create this profile, but you can without any serial number. It's better if you use KU email.
Okay, it worked. احنا بالاخر we want to create circuits, صح؟
Yes.
يعني okay, fine, it worked.
But you need the serial. You need the profile to make that.
Yeah, I did one. Okay.
Okay, Shabab, the rest are you okay?
Yes, I clicked هذا create a circuit.
Okay, sure. So this is nice. So now here I will create a circuit. Now you see here I already have some circuits built and they are saved. So whatever you build, you can come back to anytime later. So this is nice. It saves your work. Create a circuit. It will initialize. Now you have a blank page here. Okay, now here where you can build your circuit. Now let's you can save your circuit. So I will hit Control Save, or you can here from this you can save. Okay, so I will call this. It has to be public because you don't have a serial, so this it's fine. I'll call this Lab-6 circuit. Okay. All right, so this is saved. It's a dear Lab-6 circuit. You are not authorized to save.
Yeah, I got the same.
Yeah, I am logged in. What the hell? Log in. طيب.
I tried again, it worked. Try again.
Create a circuit. Yeah, let's save again. I'll call this Lab-6 circuit. Saving file. Okay. Okay, what's
are we
saved?
doing this as an alternative because we cannot attend the lab physically, or this is
No,
the usual lab?
No, this is essential. Like simulation is alternative to calculations.
Okay.
You see here you can analyze the circuit and calculate like these theoretical values. Now this simulation is alternative to calculations. So this is essential.
Okay.
The in-lab work is part B. There's a video record in this. We'll come to that. So this simulation is very important. You can, as I told you, instead of calculating values, especially when you're dealing with diode circuits, which I think you have done so by now. You have dealt with diode circuits. In diodes, you need to assume and do trial and error. So it's time consuming a little bit. So you can construct here your circuit to verify your theoretical analysis. Okay. Okay, so let's, like, as engineers, when I have a complex circuit, I usually go and simulate. I don't go derive equations and then do those lengthy analysis. I simulate directly. Okay, sure. Okay, so let's build the circuit. Now in the manual, it says you have these all of the steps in detail. Okay, so I'll summarize them and then we will fill this table, step 10. Okay, so here you see a lot of tools. You have power supply, you have sources, you have AC voltage, you have DC voltage, you have DC current source, you have square voltage sources, you have a lot of sources. So what we will need today is DC voltage source. Okay, so I'll grab this element, click here, and that is fixed. Now if you double click, you'll have the properties for the source. Now I need this to be 5 volt. Done. So this is 5 volt supply. Okay, so are you following?
Yes, معاك Mr. Ali.
Yes. So say you need a diode. Here you have list of diodes. You have regular diode, Zener, you have a LED diode, transistors. You can test your NPN, BJT, different CMOS, different types of transistors. You can even put switches, relays. You can put lamps. So all of these are essential circuit elements. I think there is even a digital circuit elements. So all of these tools depend on your application. So for us, we need 3 resistors. So let's put one, another one here, and another one here. So I have 3 resistors. Okay. Now the values, R1, as in the manual, it is 220 ohms. Okay, sure. So I'll double click this resistor here. I'll tell him this is 220 ohms, enter, and then you're done. Okay, now R2, R3, I want to rotate these, so I will click here. Okay, to make them vertical, and another one here. R1 should be 560, so double click. This is R2, sorry, 560 ohms. And R3, let's keep it at 1 kilo ohm, 1000. Okay, guys, are you following? Now I will complete this connection. Click, click. So this is like wiring, like physical wiring, like this. And I'll close my circuit like this. This one here and this one here. Okay, guys, so this is very easy. The tool is very easy. Okay, are you following?
Yes.
All right.
Yes.
All right, so here the circuit is complete, but in simulation, in order to run any circuit you need or you have, you must put a ground, which is the reference. So here, let's go here to ground, select this ground, and my ground is usually the negative of the supply, the negative terminal of the supply. Okay, now grounding is a topic. What does it mean to put a ground? Let's see, let's keep it to the end. I'll explain to you different types of grounds and their importance. Okay. But for now, this is the voltage reference in your circuit. So any voltage you will measure will be with respect to this ground. Okay, so okay, so now on the table it says measure V1 and V2, I1, I2, I3. Later on, you will calculate power N, power 1, power 2, power 3. So let's do that. So to measure voltage, you need to place from this menu here, you can put a voltage voltmeter, a voltage probe, or a current to measure ampere. This is an ammeter. So V1 is here, so I'm going to place this here. Okay, I need another one to measure V2. Okay, Shab, you agree?
What are the numbers in the circuit? 1, 2, and 0?
Yeah, automatically the simulation identified that this is node number 1 and this is node number 2, and 0 is always the ground node. So here, this node actually, you have 3 nodes. You have a node here. This is node number 1. This is node number 2. And node number 0 is always the ground, this one here.
Oh, okay.
Okay. All right. طيب. Okay, so are you following until now? So
yes.
Yeah. So here, the whatever voltage you have will be displayed in this voltmeter number 1, and this is V2 voltmeter number 2. Okay, so let me remove this and I will run my simulation. Okay, so directly here you see this probe is measuring 5 volts. You see the time is proceeding, it's moving, and you have your voltages, the circuit is running. All right, so my V1 is, of course, it should be 5 volts. So the simulation is okay, it says 5 volts. So I fill this. Yes.
How did you get values على الcircuit? I missed the high step.
Okay, I'll repeat. So let's stop this. I'll remove this.
No, I put those, but what I meant is the values, like 3.1001 and the 5.0 volts.
Yeah, just run the simulation here.
Okay, I wasn't in full screen, so I didn't show. Okay, fine.
Okay. Okay, so are you following? You all got to this step? Okay, so for example, say you have an exercise or a circuit that has a diode here. So is this diode forward biased or reversed biased or unbiased or what? So the biasing for this diode is, yeah, I think it's the default diode, so this should be 0.7, something like this. Okay, so if you run here, now you need to calculate, you need to put another voltage source. Now this is not in the manual, it's just to show you how you can use the simulation. Okay, so 3.2 minus 2.5, 3.2 minus 2.5 is 0.7. So the voltage is forward biased. The diode is forward biased. Okay, sure. All right, so this is this. Now let's bring this back to our original circuit like this. Let me delete this guy. All right, so okay, so I have my V1. Now V2 is 3.1 volts. So this should be 3.1 volts. Next step is to measure current. Now I know I1, I2, I3. Now I have 3 currents. You have I1, you have here I2, and you have here I3. Okay, so we need 3 ammeters to measure current. Now we know in order to measure current, we have to place the ammeter in serial with the load. Okay, so here, this is your current. Now you see there is an row, something around, no, at the bottom of this. It shows you the direction of the current that this ammeter will measure. So if I place this here, automatically this current is the one flowing through this wire. Okay, sure. So you need another one here. Okay, this is the current flowing downwards and the current flowing here as I3. Okay, sure. Are you following?
Yes, following Mr. Ali.
Okay, now if I run, all right, now I1 is 8.636. So I1 is 8.636. Later on, we'll compare this to measurements. So this is milliamps. Milli means times 10 to power minus 3. I2 is 5.536 milliamps. I3 is 3.1 milliamps, so let's put that. Jack, are you following? Right, you can always go back to this record to obtain these values because this is what you'll use to complete your analysis. All right, now Pn, what is Pn? The power delivered to the whole circuit. Now, how to calculate that? Pn equals what?
Is it the voltage of the source multiplied by the current passing through it?
Yes, exactly. So the voltage of the source is 5 volts. What's the current passing through the source?
8.636.
Exactly. So this is the same as I1. So you can calculate Pn as 5 times 8.636 milli. So this will give you what?
43.
8. 0.043 صح؟ Watts or 43.18 milliwatt. Okay, شباب? So this is the power consumed by your circuit. All right, P1 is the power consumed by resistor 1. What is that?
I squared R.
I squared R or V squared over R. You can do anything. If you use V, however, what is the voltage across resistor 1? The voltage across resistor 1 is, you need to be careful about this point. This is plus minus, let's call it VR1, which is equals V1 minus V2. This is the voltage across that resistor. Okay, if you decide to use voltage, it's easier to use current. So P1 equals I squared, I1 squared times R1. Okay, sure. Same P2 and P3 because we have I2 and I3, so this is straightforward. Okay, sure, you agree? All right, so these power calculations I'll leave to you. These are straightforward. Now, one thing, we said that I1 equals I2 plus I3. Is that so? Yani this 8.6 will split to this plus this. Let's verify. 8.636. Oh, sorry. 5.536 plus 3.1. This is 8.636. So exactly, you have the current law verified. Okay, so power generated by DC power supply, this was already Pn. Power consumed by R1, R2, R3, these are P1, P2, P3. Now, step 12 says paste a link from online where you can buy a supply that satisfies the minimum power demand of the above circuit. Okay, guys, so I have a circuit, say this is your load. Your load is taking 8 milliamps at 5 volts. Okay, so you need to find a power supply that can operate the circuit, giving its load condition at these values. So this is a simple research thing. Go online, find a DC supply with specs that satisfy these values here. Okay, sure.
Okay, tamam.
All right, so at this point we have finished the simulation. Now this is equivalent to theoretical calculation. And if you derive the equations manually and calculate I1, I2, I3, your value should be exactly as what you obtain here. Okay, so this tool is like theoretical analysis only through this simulation tool. Okay. Let's stop. Okay, Joe, any question before we proceed to experiment?
No, okay.
Okay, so next step is to really construct the circuit. We will measure resistors. We have 3 resistors. Okay, let's go down. We have R1, R2, R3. Now the theoretical values were given to me before, but now I'm going to measure them. So we'll see how we can use the ohm meter in order to measure 3 resistors and compare the measured value to the theoretical. And this theoretical value is what you got from simulation, or in that sense, the simulation was fixed, and the values in simulation are already given. So these are given to me. All right. Now, when I measure them, I will go and measure the V1, V2, and I1, I2, I3. So all of these steps will tell you how to proceed. After we finish, we will compare the power simulated to the power measured. All right, so this will conclude our lab, is to really measure. All right. Now I've made a video, a very, very clear video about how to perform this experiment. Okay, now the video is there in the, if you go to the channel, here there's a YouTube video that explains all of the steps in a clear fashion. All right. Now I'll try to open the webcam, and let's hope that it will be clear. All right. If it is not, you can always do the video. So my recommendation is to watch that video. Now, how much time do we have? So we have less than 30 minutes. So the video is like 30 minutes. What we'll do now is we'll take our data to save some time. And watching the video, I highly recommend you can do this by your time. Maybe tonight or as soon as possible, you watch this video. It gives you exactly the steps that we'll do today. Okay. All right, so let me open the webcam. Let's see. Now, where is my webcam? All right. Okay, how clear is the device?
It's clear, but pixelated, so we cannot see details.
Yes, you cannot see detail. All right. I don't know, if you run the video, we will waste time on that. Yeah, it's not clear. I knew it. Okay, so we will proceed, but I'll show you where in the video you can find the steps we are doing. So instead of watching the video, maybe you can pause the video at some time instance where we are currently doing that step. Okay, so let's open the video. Now this is a YouTube, so you can control the resolution. You can make it high resolution or low resolution if you have a slow connection. All right, so it has details on what's the breadboard. I already step. Okay, so let's proceed. It explains what the breadboard is. Okay, I will leave it loading. Okay, these are trivial steps. Step 1, 2, 3. This is to power on the device, connect the resistors, and measure their values. Except that we will be dealing with a breadboard, or what is called here on the Elvis platform is called proto board. Okay, sure. Did you deal with breadboard before? I need to hear from you how familiar you are with breadboards.
No, I personally did not deal with that.
First time.
First time, perfect. So let's explain what they are. Now in the video I put a boring detailing about breadboards. They are very simple, but this picture here will summarize. Okay. Now here in front of me I see like these terminals, these holes, and on the left here you see this is the backward of the breadboard. Okay, now in the video if you go to I'll give you specific time. Okay, all right, I think the time is 2. The timeline is 2. If you go there on in the video, yeah, it is slow because I am streaming a lot of things. Yeah, so this is I think the time is around 2, something like this. No, it's 1:53. So there you have strips. You see these strips on the breadboard. Okay, this is actually the back side of the breadboard. So you can see here I have like these metal conductors. You have left and right. So you have rows like this, and here you see you have columns of these conductors. So what are these? Here in the I can see here in the this figure. Now each one of these to the right. Okay, you see here there's a number 10.
Mr. Ali, are you explaining? Never mind.
Yeah, I'm sorry, I have to switch between manual and video. So
Yeah,
this is.
but like, I thought it's from my side. It's fine.
Yeah. So now on the manual, here you have number 10, and you have this line here. So all of these are connected using one conductor from these. And the same on the left. So this is here. Okay, so now why is it this way? But of course the left is not connected to the right. They are independent. Okay, same way you have many nodes or many lines like this. Each one of these lines is connected internally using one of these conductors. Okay, the same you have these vertical lines. So this is this line here, for example, is the blue one. Now this is maybe this one here, and here you have that one here. So you have all of these horizontal, these vertical lines. All of these terminals are connected internally through one metal conductor. Okay, so anything I wire to say this one here, it will be available in all of these terminals. Okay, Shab, you understand?
Yes, sort of.
Okay. So how to use this breadboard? Now this is very simple. Why do I have it this way? I'll switch to the camera, and I will hope that you can see it in a clear way. Okay. Okay, in front of me here, I see many of these breadboards. Okay, maybe I can zoom. All right, you can see here you have 1, 2, 3. You have 4 copies of this breadboard. Okay, Shabab. Now, if I zoom the camera, let's see if I zoom like this. Is that better? At least if you can see horizontal and vertical lines.
Yeah, it is good.
So here you have these horizontal, where should we explain? Yeah, here. So you have these horizontal lines, this one here, and there's another one here. Okay, so you have another line, so you have many lines. Okay, so each one line is just one conductor. It's like all of these holes are connected. Okay, on the left side, you have the same. Okay, and you have two vertical like this. There is a blue one, a red one, and another two like this. Okay. Now I'll show you another breadboard that is external. Yani these breadboards, they don't have to be an Elvis. Okay, this is another breadboard. Okay, how should we do that? Okay, so you can buy this from the market. So breadboards are available anywhere, and they are cheap and easy to use. Why do you use them? We use them to construct circuits in a temporary way. And I want to connect and disconnect elements and connect resistors, ICs, etc. But I don't want to solder them. And the benefit is that you can connect circuits by mechanically connecting them to these terminals on the breadboard. If you solder any element, now it is permanent and you cannot disconnect it. So breadboards will give you the choice to avoid soldering. Okay, guys, for example, here, how clear is that breadboard?
Not so clear, to be honest.
Okay, it's not clear. طيب, let's go to in the video on YouTube. If you go to the time, this time 2.09 or something around 2, I explained just that. Okay, it shows these lines on the breadboard. Okay, Shabab, so why do we have this left and right nodes? Now this explained in I think minute 4:13, 4 minutes 13 seconds. Okay, let me see an alternative way to do this. Okay, Shabab, you see the image here?
Yes, clear.
Yeah, this video instance here, it shows how I can connect an integrated circuit to my breadboard. So basically, you see the legs of this integrated circuit. You can plug them to the breadboard and access the connection to those terminals through wires. Okay, so let me capture this screen and I'll explain it in OneNote. Okay, so I will go to OneNote. Okay, let's see about breadboards here. Okay, so I can see here now this terminal, when you plug it to this node, it's node number 4. Now the connection to this is available here, here, and here, and here. Okay, now this terminal, again, it's available here. Same, all of these legs are accessible. We will use wires to connect these terminals. Okay, so you don't have to solder, you just plug this board. Once you finish, you can unplug it. Okay, Shab, you understand breadboard? How clear is that?
Clear Mr. Ali.
So again, the video explains in better detail what you are doing here. Okay, the explanation of breadboard. Okay, so what I will do now is again explained in the video. Okay, but I will do it in the lab. The point is to have our resistor values. Okay, so to save the time, خلينا نرجع المانيوال. Okay, I will fill the tables, but you have to promise me you will watch the video by your own. Okay, we could watch it together now, but it's a waste of time. You can do it by your own. Okay, شباب, you all agree in this?
Yes, okay.
Okay, sure. So this saves you time, and I think you have a quiz later on or some exams. All right. Okay, so directly to table and step number 10, where I'm going to measure my resistor values. Okay, sure. Now, here in this view, I have two probes. Now, all of this is explained in the video, so you will not lose any of this information. Here, I'm going to use the digital multimeter. Now, I've seen last time we used the oscilloscope, the function generator. Now, I need to access my digital multimeter. Okay, so this is done here in this digital multimeter connector. Okay, let me zoom this. Okay, guys, you see the terminals? Okay, so here, this terminal, the DMM, I think all of you are familiar with DMMs, the physical DMMs. Should we explain?
What are DMMs?
Yeah, should we explain? Okay. So digital multimeter, I'll show you a handheld digital multimeter. Okay. So this one is a digital multimeter.
Ah, okay. I'm familiar with this, but not the first one we were seeing.
Yeah, that one is on the this. So what is this DMM? You can measure. خليني أحاول أقرب شوي. Is the font clear here in the terminals?
Yes.
Kind of, okay. So here you have V and omega. So this is used to measure voltage and resistance. COM is common. It's like the ground of the device. You have milliamp and 20A. So these two are to measure current. So you have several terminals depending on the measurement you want to do. For example, I want to measure voltage. I'll plug my terminal here, my probe. So I'll plug one of them here and the other one to common. Okay, like this. All right, and here on the device dial, you need, what do you need? Voltage DC. You see this symbol? This is voltage DC, and here this is voltage AC. Okay, Shab, you agree? So, and I want to see if your the car battery, is it fully charged or is it not charged? What do? You select the range. Here I have the range. This is manual, so I have to select the range manually. Okay, so here you have different ranges. You have 2 volt, you have 20 volt, you have 200 volt, until 1000 volt. This is the maximum range of this device. Okay, Shabab, you agree? Now, if you want to measure AC, you have to go here to one of these ranges. So you have 2 volts. This means it will measure up to 2 volt AC. For example, the power from the socket, wall socket, is 240. So you have to put 750. If you put 200, it will not measure. It will give you over range. So I go to the next one, greater than my expected value. Okay, so how clear is that?
Yes, clear.
All right, so this is handheld digital multimeter. Right. Now the same here, the Elvis has that, but I see just 3 terminals. Okay, you see here, this is digital multimeter, and there is V, omega, and diode. This terminal used to measure voltage, resistance, and forward bias for a diode. This is the common, and this is the current measurement terminal. Okay, guys, you get it? We can repeat and spend time on this until you feel comfortable. It's important to understand multimeters. Should you explain on using pictures?
Yes.
Let's see. Okay, so what I will do, I'll take a picture using my phone. Okay. I need to stop sharing for just a second, and I'll show you a clear picture of that. All right, so let's share again. Okay, guys, how clear is that?
Very clear, doctor. Better.
Too clear,
much better.
too clear, huh?
Very wide.
All right, so this is exactly what is there on the Elvis board. You can see here that this is. I should be able to edit. I need to copy the picture. Finish twice. Sorry about that. Copy paste and reopen it from here. Close this. Zoom. And that's it. All right. Okay, so you can see here that I have, let me draw. Okay, this doesn't zoom high. Yeah, I should be able to draw over the picture. All right, so here on this side you have the V and omega. So V means voltage. We will see how we can use this to measure V1 and V2. Omega, what does it mean? Who can tell me? Resistance. Okay, guys, the common is always the negative or the common terminal on the emitter. and the multimeter. Okay, this one is used to measure current. Let's do that here. Okay, guys, so whenever you want to measure voltage or resistance, use this terminal. Whenever you want to use current, use this terminal. So what I'll do next is the following. I'll connect a probe here and another probe here. I have my resistor. Then I'll connect them together this way. One here and one here. Okay, guys. Now to do this, let's take another picture. I'll fix a resistor on the breadboard and I'll show you how we are doing this. Okay. Let's take a picture of that. All right, I'll import it from my phone. All right, so this is what we are doing currently. Okay, what do I have here? Okay, guys. Now, is it clear?
Yes.
Okay, so we'll take this to all right. So this is my breadboard. You see here that the node number 30 is this one. Now I've connected this lead here, this one of the resistor, directly to this lead 30, right? So all of these holes, this one here, this one here, this one here, and this one here, all of them are internally connected to the resistor. Okay, shall we agree? Now another node is 40. I have one leg or one terminal of the resistor connected here to this. You can access this by plugging a wire, or in this case I'm using this is the probe lead. Okay, so it's plugged here. You can see him plug it here, here, and here. All of these are internally connected using the metal strips we have seen. Okay, using the metal strips in the manual or in the picture as we have seen. Okay, sure. So now what about the rest of the nodes? These are floating. These are not connected to anything. Okay. So I'll do this for R1, R2, and R3. Now this one here is the resistor. Okay, and from the colors, you know, Shabab, you know the color code of the resistors?
I know that there are different colors for different resistances, but I'm not sure of the specific colors here.
Yes, so basically there is color code for a resistor. Now this helps the technicians to identify the resistor value from the color. So there is like there's like color bands. Here you see there is one color. This is actually brown. This is brown. So browns, there's a table, reference table for this. So brown means 1, black means 0, so I put another 0 here. And the third band here is just a multiplier. So red means 2, so times 10 to the power 2. The gold is the error, tolerance of the resistor. So if you Google it, you will see there is a table, standard table for these. Okay, always the first 2 digits from the first 2 colors, and the third color is a multiplier, just a multiplier. So basically this is 1000 ohms. This is the 1 kilo ohm or my R3. Okay, so this is the color codes. You don't have to know them. It's just it's good to know that there is a color code for these resistors. Okay, just extra information. All right, so this one here in front of me, I can see the 1 kilo ohm. Okay, I'm going to connect to the device and I'll show you how to get that value. You don't have to do this, but this is how you can run the DMM. Same way as we did last lab. Now this time, I will not go to measurement live and put a device ID. I'll directly put the IP address of the Elvis board. If you're connected to Pulse Secure, you can do the same. All right, so here, let me put my name. And in the instruments, all of these steps you have seen before. Now what I need is the digital multimeter. Oh, the device is not connected. Why? If I don't see a serial here, this means the device is not connected. Let me just verify the IP address. Oh, I need to reboot the device. Now I could do it the same way using the handheld multimeter. Okay, so any multimeter will actually work. Okay. I'm just waiting for the device to boot. Okay. Okay, now I have the serial number here, so the device is operating, and I need to add a digital multimeter. Okay, so this is a digital multimeter. Now it's the same as handheld, but now you see here the range is automatic, so the device automatically will identify the range. And the manual one, let me show you that on the camera. Okay, the manual one, you have to select the range manually. Okay. Okay, see, so here you have to select that manually, the range. Okay, now here, I'll switch back to my digital multimeter. So this is automatic. Okay, now what do you need to measure? This one is directly voltage. You can see here DC voltage. Okay, Shab, what about this one? Who can tell me what this one is?
AC voltage.
AC voltage. So if I click this, AC voltage. طبعا using the same terminals. You see the highlighted terminals here are exactly the ones here on the device. Okay. So it says use these connectors. Tic-tac, these are exactly these. Type. What about this one?
AC, DC current.
DC current. This one?
AC current.
AC current. This one?
Capacitor.
Yes.
Oh, passive.
So you can use.
لا مش passive. No, it's a capacitor.
No, this is dedicated for capacitance.
Yeah.
The capacitance, it has given you different terminals. It tells you use these terminals. And the picture here, are we clear? Yeah. So it tells you to use these terminals here to measure capacitance. Okay. And other things. So this is why it's called multimeter, because you can use you can measure multi things. Diode, the bias voltage for a diode is measured practically here. Inductance, you can use measure inductance. This one is for continuity. It's very useful to know if a wire is broken or not. Simply the device will generate a sound if the line is not broken, if it is continuous. So if I run now, let's see. I don't know, did you hear the sound?
No.
Okay, from my side, the sound was so loud. Let's see, does it go here?
Yeah, okay.
Yeah, okay.
So this means what I'm doing here, if you see the camera, let's go to the camera. Yeah. So this guy. So I've connected the two probes here to these terminals, and here on the thing I'm just connecting. So when I connect like this, you see like this. Okay. So for example, you have a wire, just a wire. That wire is can be connected to a sensor or to a motor or whatever, and the motor is not working. So what you need to do is just bring this wire like this and connect your continuity mode to the edges of this wire. I don't see a voice. So yeah, so basically my wire is not broken like this. Okay, so this is the continuity mode on the multimeter. Let's go back to the multimeter view here. All right, so I'll begin with measuring resistance. All right, over means it's over value because my probes are not connected. So what I will do, I'll connect them this way to R1, R2, and R3, and we will record the values in the manual here. Okay, so let me begin by R1. Now I'll keep the camera open, although this might not be so clear, so I'm going to work in this area here. Okay, so R1 is this one here. I'll connect it to any two nodes like this, and connect probe 1, click, and click this way. Okay guys, now what's the value here in the DMM? It says 218.5. So here let's write this 218.5. Okay, Shab, are you following?
Yes.
All right, theoretical it was 220. So I see here.
Doctor,
Yes.
can I leave because I have a quiz after 5 minutes?
Okay, no problem. But Zaid?
Yes.
Okay, Zaid. Okay. Kishab, so you can leave because this is summarized in the video, all of this. Okay. But
sir, also me, please.
Sorry.
Also me, we take a vibration. Yes.
طب ليش الكويز بوقت اللاب؟
I don't know. He said that will start 5:25.
طب tell him you have a lab يعني.
مشكلة بالدكتور يعني من شهر وهو يأجل، ما أدري شو عنده. وكلهم قرروا على الوقت.
طب next week ممكن نعمل كل كويز معناته على 6 أو على 7 مثلا.
ليش اليوم الكويز؟
لا next week.
اوكي زين اوكي
يعني we don't have to do it in the same time as the lab. We have flexibility. خميس مثلا أو الاثنين أو عشان نعمله common لكل السكشنز.
الخميس إجازة.
الأربعاء نضبطوا الأربعاء بنضبطوا بأي يوم.
يعني والله باكر دكتور؟ يعني هالأربعاء؟
لا الخميس هذا إجازة، بس الأسبوع الجاي ممكن نعمله الأحد أو الخميس أو whatever.
في مشكلة.
طيب ما في مشكلة. So زايد وأحمد you can leave so it's fine. Okay شباب, so let me take attendance. بعدين راح.
دكتور.
Yes.
معاك عبد الله. انا عندي امتحان الحين كوز فايبريشن.
طيب.
انا وزايد والخميس ناخذ الفايبريشن الحين عندنا
طيب،
كوز.
ممتاز
انا
ممتاز. خلينا اخذ attendance بسرعه and then you can leave. اوكي، اللي ظل بسيط جدا. راح نعبي التيبلز بس، والخطوات العمليه مشروحه بالفيديو بشكل مفصل يعني، لانه الكاميرا مش راح تكون واضحه. شو هذا؟ ليش يطلع عندي بالشكل؟ اوكي شباب، فحتى ما تتاخروا you can leave already know your names. اوكي
شكرا دكتور، يعطيك العافيه.
فيكوك. بثينة معنا؟ طبعا اللي ما عنده امتحان ما يغادر ولا لا؟ اوكي بثينة معنا. منى الحوسني.
يس سر.
كيو. عبد الله الحوسني. عبد الله اتوقع طلع قبل شوي. اوكي. احمد الخميسي. احمد كمان كان عنده امتحان. اوكي عبد الله، بس احمد كمان عنده امتحان ولا؟
دكتور زايد واحمد
عنده امتحان.
سو اوكي، نوار معنا وزايد طلع ومحمد المناعي.
نعم.
محمد معه. اوكي. مريم المهيري. رايت. وفاطمه مرشدي معنا. اوكي. وعبد الله الرحمه. عبد الله.
يس.
عبد الله. ومحمد طنيجي عنده امتحان ولا؟
يس.
أوكي.
وياك دكتور.
اوكي. هاجر معنا كانت صح؟ وين هاجر؟ رايت. وكريم يوير with us رايت. اوكي تقريبا الكل حاضر. اوكي شباب، اللي عنده امتحان you can leave it's fine. I'll continue. راح اعبي التيبلز وكل التفاصيل مشروحه بالفيديو بشكل كثير واضح. اوكي، فبصفي بس تعبئه التيبلز الحين. اوكي طيب، قسنا R1 R2. راح افصل R1 مباشره واركب R2 in the same way. R2 راح تعطينا الاناليسيس راح تكون بناء على الفاليوز هاي شباب اللي بناخذها هني، مش بالفيديو المسجل. الفيديو المسجل بس اكزامبل كان 549.3 سو 549.3. هاي R2. R3 خلينا نشيلها. اوكي اعطتني 987. 987 ونص. اوكي طبعا theoretical values معنا already هذول. تمام. اوكي someone with me at least. طيب error you can calculate error theoretical minus measured. هذا اللي هو الايرور difference only مش percentage. اوكي الحين I will construct the circuit exactly this way. شو اللي بصير عندي؟ راح اشرح عليها بسرعه السيركت هاي. let's expand this picture here. All right, so what do I have here? I have connected the variable power supply. You will see that this is the positive terminal. I've connected it to one of these red lines. which means you can access the power from here, whatever, wherever you want. Okay, so all of these, they have whatever voltage here you have. Let's say this is voltage N and this is the plus. Now the voltage N minus, I took that and connected it to any of those. So basically this wire is connected to the negative here, to the blue line. So all of this is, not all of this, is just a wire. So here is connected to all of these. All of these are the negative of the supply, and all of these are the positive of the supply. It's in the video again explained. Now R1 is between node 1 and this basically will be node 2. عليها voltage 2. Now the current will flow this way here through R2 and it will split. Let's put that maybe in orange. This is the current like this. It will split to I2 and I3, and my I1 is this way, I1. And it will come back this way, and to the supply it will continue. Okay, this is my connection. Okay, and I'll connect this, and you can see it with the camera, though it's not clear. Again, the video explains everything. Okay, so this is my R1. Where's my tweezer? Okay, R2 is connected here, the same node as R1. Okay, and here I'll connect back R3. Okay, now the power supply, I'm going to connect it. Okay, this way. The best way is to take a picture for all of that and explain to you. All right, so let me import that picture. It's not both English. Stop sharing for just a moment. Okay, let's bring back the sharing. Okay, this is my current connection. This is the connection that I'm having. Okay, let's rotate that. All right, so you can see here I have the power supply. This one here is the power supply. You have plus and minus. Now these two terminals are connected here. Okay, these are hookup cables. They are connected to TP1 and TP0. And I can see here there is the this purple line and the black one. They are connected directly to the plus. The red line and the negative is connected to the blue line. And then from those the red and blue lines, I take this positive, this one is the positive power supply. Okay, now you just think about this is connected here directly, and the negative is connected here, and through this orange it's connected here. Okay, sharp. So this is connected this way. Done. Right. Now this is my R1. This is R2. This is R3. You can see all of this now. All of these are node number 2. This is V2. Okay, and all of these now are V1. And this node here is the ground. Okay, Shabab, I hope this image is clear enough. Again, the video has better details. Now